Hello and welcome everyone. This is Mohammed Inzamam from SAIMEDHA Coaching Center, Koti, Hyderabad. As promised, every day oka video, free content, SAIMEDHA Koti, Hyderabad, the YouTube channel lo update avvabotundi. In this video, we are going to be providing the free content for AE-AEE Civil aspirants koraku. Subject is Fluid Mechanics, Chapter 1, Fluid Properties. So, ee video lo manam cheptukunedi topics emunnayante Fluid Mechanics, Continuum Mechanics, Nuts and Number, Mean Free Path, Characteristic Length, a basic regarding the properties, fluid and its deformation. So these are the topics guys that we are going to cover in this very video. Video ni full ga watch cheyandi. At the end of the video guys, I'm having a exciting news for all the AE-AEE aspirants. And one more time, those who have not subscribed this channel guys, kachithanga is channel ni subscribe cheyandi. Prati okka roju free educational content we are going to be updating in this very YouTube channel. Press the bell icon to be notified for the every update from SAIMEDHA Hyderabad and join the Telegram channel. Let's get started now. Let's observe. In this very video, we are going to talk about the introduction part of the fluid statics, fluid kinematics, fluid dynamics, what is fluid, what is flow surface, what is the free surface. Regarding that, we are going to discuss in this very topic. Okay. So, starting with the fluid statics. What do we know about the fluid statics? The science which deals with the behavior of fluid under rest condition. So, we can write in one word, fluid under rest. Fluid under rest. Rest where there is no motion, the fluid velocity will be having equal to 0. So, velocity equal to 0 and there is no velocity. Under this condition, okay, what we can say, you will be having some applications here. In the fluid statics, we will be discussing about, suppose the first one is overhead tank. This is a tank in which we are storing some water. Focus on the force distribution diagrams. Okay, with some pump we have transferred the water. Let's say here we are having the pump, it is transferring the water here. So the water is getting filled, it will be exerting a load over this bottom face. Which type of load it will be exerting? It will be exerting a uniformly distributed load. So what is the example number 1 that we have discussed? A body flat surface will be subjected to which type of force? This force is uniformly distributed force. It's called as UDL, uniformly distributed force. Okay, so example number 1 is overhead tank. This we need to discuss here. Followed by, we will be having vertical walls also. Suppose this is a vertical wall of a dam. So over this vertical wall of a dam, also some fluid is there here. It will be exerting some pressure. Focus on the diagram. Which type of forces we are having there? That is, we are having a uniformly varying load over this vertical wall of a dam. Okay, as you can see, this is hydrostatic pressure distribution diagram. The word itself indicates, what is it? Hydrostatic pressure distribution diagram. Hydrostatic pressure distribution diagram. Hydrostatic pressure distribution diagram, what is the shape? Can you tell me now? Its shape is right angled triangle. Shape could be appeared question. Shape of the hydrostatic pressure distribution diagram in a vertical wall of a dam. Vertical wall of dam. Okay. Next one, which type of loading is there? Which type of loading is exerting there? Uniformly varying load. What is it? Uniformly varying loads. Okay. Sometimes ask the formula also here. The formula I am writing, that is pressure is proportional to depth, height power 1. That means pressure increases. How the pressure is changing there? How the pressure is increasing? Pressure is increasing linearly. This will be your answer. Power 1, na? Power 1. Power in 1 indicates it is linearly. If it is square, then parabolically. Logarithm, some ln is there. Exponential, some e power x is e power y is given in the question. Formula. Okay, the formula is going to become pressure is equals to specific weight. This is gamma times of h. Pressure changes with the change in the height. Then hydrostatic law, that is dP by dz is equals to minus gamma. This formula's derivation we will see in the statics concept. Okay, for now this is only introduction. Example number 3. Example number 3 is floating bodies. Floating bodies. Whenever bodies are coming partially or fully in contact with water, it will be experiencing a upward thrust force. This upward thrust force is called as buoyancy force. Vertically upward. Vertically downward force which will be trying to sink it down, that gravitational force called as weight. This is gravitational pull or gravitational force. Buoyancy is upthrust, vertical upward force, upthrust. Okay, this was given by a principle called as Archimedes principle. What is it given by? It is given by Archimedes principle. Okay, so this is all that we are going to discuss. Vertical wall of a dam are there, floating bodies are there, floating bodies and submerged bodies also will be discussing inside the statics concept. Submerged bodies also, submarines. Okay, submarines which are there inside the water. Inside the water. Then it will be having vertically downward force, that is weight acting at the center of gravity. Vertically upward force, that is called as force of buoyancy. Okay, depends. Under what conditions these are going to be stable, unstable and neutral, we will see in the hydrostatics concept. Okay, so this is all about the fluid statics. And the next one we have here is fluid kinematics. Fluid kinematics. Fluid kinematics is a science which deals with the behavior of fluid. Behavior of fluid. Studies the behavior of fluid under motion. Under motion without consideration of forces. Without consideration of forces. Okay, we will be talking here in this case about velocities, acceleration. In the types of acceleration, we will be having acceleration in x, acceleration in y, acceleration in z. Then in turn in the acceleration concept itself, we will be talking about temporal acceleration, temporal local acceleration, convective acceleration, normal acceleration, tangential acceleration. Okay, then we need to discuss about that is types of flow, types of flows, steady flow, unsteady flow, uniform flow, non-uniform flow, one dimensional, two dimensional, three dimensional, laminar, turbulent. When we discuss about laminar and turbulent, then we need to discuss about the Reynolds number also, a non-dimensional number. Reynolds number. Based upon that we will be analyzing then what are the losses inside the pipes. Losses in pipes. Again in the losses of the pipes will be major losses will be there, minor losses will be there. We will be having a separate concept of flow through pipes to study this major and minor losses. Okay. Then we have applications, not only the pipes as well as open channels also we have. There we need to discuss about all these losses. When we discussed about power calculation, work done calculation, efficiency calculation, that goes under entirely for dynamics concept. So for now we need to know about this basic two examples I am covering here. One is nozzle. Nozzle, when the flow lines are coming towards each other, flow lines are coming towards each other, that is flow patterns we need to study in the kinematics. In the flow patterns we will be learning about flow lines, stream tube and flow net. In the flow lines again we will be having path line, streamline and streak lines. Okay. When the flow lines, these streamlines are coming closer to each other, streamline spacing is inversely proportional to velocity. Remember this. When the spacing decreases, then what happens to the velocity? Velocity increases. And this device is called as what? Nozzle. Vice versa with the diffuser. Diffuser is working opposite to that of the nozzle. Okay, area of the cross section is increasing from entry to exit. Here the area of the cross section is decreasing. When the flow lines are moving away from each other, then what happens? Spacing is increasing, flow line spacing increases. What happens to the velocity? Velocity decreases. But discharge will be entirely remaining constant. When we discuss about this streamlines, then we need to discuss about some mathematical equation also, that is called as stream function, potential function. Stream function and potential function. This stream function, potential function, flow net, okay, this will be seeing in the kinematics concept. Followed by the next concept that we need to talk about introduction is fluid dynamics. Fluid dynamics or fluid kinetics. So in this concept, what are we going to discuss? This chapter studies behavior of fluid under motion with the consideration of forces. Okay, with the consideration of forces. The first example is very simple to understand. That is, here we are going to talk about all the jets, okay, which are going to be providing some kinetic energy by means of a nozzle. Nozzle we discussed in kinematics. This water is coming and now it is converting this kinetic energy into work energy by means of a turbine. So turbine comes under what now? Dynamics. Okay, generating the power, and remaining water will be falling into the device called as tail race, which is going to be carrying the water from the exit of the turbine to that of the channel. Okay, here this is penstock. Just an introduction part, guys. Here we have nozzle. Inside again nozzle will be having spear rod. Here we will be having a deflector plate. These are blades, double hemispherical ellipsoidal blades. Then it is called as a runner. Okay, then we have at last shaft. Here we will be having a jet which is going to be transferring the water from the reverse direction, that is braking jet. To avoid the splashing of the water, we are having a protective casing. Okay, so this comes under water dynamics, that is water turbines. Water turbines. These turbines followed by pump also. Okay, second example we are going to discuss about is pump. Pump is a device which is going to be taking the water. Actually, it is going to be taking the energy from motor. So motor is supplying the which energy? First of all, electrical energy is provided to the motor. This electrical energy is converting into shaft power. This electrical energy is converted into shaft power by means of a coupling. So this shaft power of the motor is connected to the pump shaft by means of a coupling called as fluid coupling, hydraulic coupling, and this shaft power of motor is connected to shaft power of pump. Pump will be taking the water from lower reservoirs, lower level reservoirs, and it will be supplying it to some high pressure reservoirs, not high pressure reservoirs, some overhead tanks. Okay, overhead tanks we have discussed in the static itself. So that's how it is going to be transmitting the power. So pump also, water pumps or hydraulic pumps also we need to discuss in the concept of fluid dynamics. Okay, go through the diagram, pause the video and note it down. So this is all about the introduction parts of statics, kinematics and dynamics. Many more devices, many more formulas are there. When in detail when we discuss about the separate individual topics, then in detail we are going to discuss about it. Okay guys. So now go through it from the first slide itself. Fluid statics. In the fluid statics, what are the examples? In the fluid kinematics we have many concepts are there, many flow through pipes, many devices also we need to discuss in the kinematics concept. And the further last one is dynamics. So in short, I have divided the hydraulics into three parts: statics, kinematics and dynamics. If we move on further, what is actually meaning of fluid? Okay, fluid, this is very most important definition. Okay, fluid is a substance. Fluid is a substance to which if we apply a tensile force, it's not going to deform. Compressive, you cannot compress a liquid. Then what we need to apply are shear forces. Fluid is a substance which deforms under the application of options. You will be seeing like this: small tangential forces, small shear forces, small shear stress. Okay, among any of them is applied, then only what happens? Fluid will deform. Here deformation indicates what? Fluid in motion. Observe here this diagram. When you apply a tangential force, shear force to it, then what happens? A fluid droplet, it start moving or not? Yes. Fluid droplet is changing its position from point 1 to point 2. Let's say this change in the position is equals to dx and this is dy, creating an angular deformation. Let's say it is shear strain. So fluid under motion means fluid is under deformation. Which type of deformation? Fluid is under angular deformation. This angular deformation, another name is shear strain. Fluid is under shear strain. So when fluid is under the shear strain, it will be due to shear stress. Fluid is under application of small shear forces. What if, now the question appears, what if shear stress is equals to 0? If shear stress is equals to 0, then shear strain equals to 0. If shear strain is equals to 0, deformation 0. If deformation is 0, that means fluid is under rest. Fluid is under equilibrium. So the question how is going to frame in the examination is, fluid is under equilibrium under what condition? What is the answer? Shear stress is equals to 0. Okay. A surface will be regarded as free surface when it is under the equilibrium condition. So whenever it is under the equilibrium condition, the surface is called as free surface. So now the question appears is, when the surface of the liquid is under free surface, or a free surface will be called as a surface will be called as a free surface under what condition? A surface will be called as a free surface under what condition? Shear stress must be equal to 0, because free surface indicates it is in equilibrium. Equilibrium means rest, motion means shear stress exists, rest means shear stress is equals to 0. So that's how easily we can identify the definition of the fluid. So one more time, what is the definition of the fluid we have here? Fluid is a substance which deforms indefinitely, continuously under the application of, fluid deforms indefinitely, continuously under the application of small shear forces, small tangential forces, small shear stresses. If you see regarding the free surface, how many free surfaces are there for the solid body? Suppose this is a solid body, here we are having one surface, this is second, this is third, bottom is fixed. So solid is having how many free surfaces? 3 free surfaces. Whereas in case of liquids, liquid is having only 1 free surface. Liquid is having only 1 free surface. Whereas for gases, gases cannot be kept inside the open container. Gases will be there inside always closed vessel. Closed vessel. For gases, how many free surfaces are there? 0. That means no free surface. In case of liquid, this is the question important. What is that question, sir? In liquid, a surface is regarded as free surface. A surface is regarded as free surface when dash. What is the answer? Shear stress is equals to 0. Go through it. Let me go back. Chalo, pause the video and note it down regarding the fluid definition, and then we have regarding the free surface. Chalo, pause the video and note it down. Congratulations everyone, you have made it so far. This video watch chesarante kachithanga mee knowledge lo some points definitely could have been added. So my dear students, sir, what is that news? SAIMEDHA Hyderabad is launching new course for AE-AEE in the app Space Gate and conducting a SST Space Scholarship Test and providing 100 up to 100% scholarships, guys. Those who are going to be securing much well marks, definitely వాళ్ళకి 100% scholarship వస్తుంది. Minimum ఎవరైతే attempt చేస్తారో examination and scoring minimum marks, guys, starting percentage of concessions are 85%, 87%, 89%, 90%, 91%, 100% వరకు full scholarships అనేది మీకు ఇవ్వడం జరుగుతుంది. సార్ టాలెంట్ టెస్ట్ ఎగ్జామినేషన్ కి సిలబస్ ఏముంది? ఇదే సబ్జెక్ట్ ఫ్లూయిడ్ ప్రాపర్టీస్, ఫ్లూయిడ్ మెకానిక్స్ నుంచి మీరు టాలెంట్ టెస్ట్ ఎగ్జామ్ రాయబోతున్నారు. సార్ వేర్ ఇస్ ద ఎగ్జామినేషన్? SAIMEDHA Hyderabad premises. When is the examination? 11th February 2024. ఇదే month morning 10 o'clock to 10:30 examination is going to be completed, followed by a guidance program, and definitely guys, you are going to understand this program. What is the importance? Everything is going to be explained there. So my dear students, what are you waiting for? Join our Telegram channel. I'll provide the link in the description and download the app Space Gate. Prepare well for your examination and don't miss this opportunity. Endukante 100% scholarships already batch 1 అయిపోయింది. This is the batch 2 we are starting. And my dear students, subscribe the channel, press the bell icon, join the Telegram channel with one more video. I'll come back tomorrow evening. Thank you very much. This is Mohammad Inzamam signing off.